Hello everyone, we're just doing the short clip for balancing equations. I'm doing this clip because I get asked the same thing quite a few times, and to save me from repeating myself, maybe it might be more helpful for students to watch this at home. So a common example is the reaction between nitrogen and hydrogen to make ammonia. Really common for the Haber process and during equilibrium. So really this arrow should be a reversible symbol, but just for simplicity today, we are going to stick with the one that I've used. So we have some nitrogen, we have some hydrogen, and it makes ammonia. Now we have to just include the state symbols. Gas, gas, there we go. Oops. Okay, so really straightforward. The way I begin is I always tell my students to split the reactants, which are our ingredients, from the products. So I do that by doing a nice straight line, a little bit like a shopping list. We're going to check now what we have. So on this side we have nitrogen, we have 2 molecules, so we put the number 2 there. Hydrogen, we have again 2 molecules. Moving over to the right hand side, the product side, nitrogen here. Now if you recall, there's no number after it or in front of it, we assume there is 1. So nitrogen, there is 1. Say chemists are a little bit lazy, we don't like to write the 1, but really it's there, okay? Now hydrogen does have a 3, so therefore we have 3 molecules. Okay, so now we need to balance it. You can see there's an imbalance here, and there's an imbalance between the 2 and the 3. I would always start with what's easiest to change. It's really difficult to change that 2 using whole numbers into a 3 and vice versa, a 3 into 2. So let's just start with the nitrogen. So what do I need to do in order to make this nitrogen double in quantity? Now the rule is you cannot change the chemical formulae, so you cannot write a number 2 here. So what you can do is write the big 2 here. Now what you're essentially saying is, in my container I have an NH3, and now I'm about to add another molecule of NH3. So I've increased the number of molecules of ammonia, so therefore I have now this big number affects the number of N's, so I've got 1, 2 now in my container, so cross this out, change that into 2. Now I've also doubled the number of hydrogens, so you can't leave that number as a 3 anymore, so you've doubled it. Now you can easily just count from there, it's 6 hydrogens in total, or just do 2 times 3, which is 6. Moving on now, so this is another step that I like to do, just for clarification. These 2 are the same, so they are now balanced. However, we still have an issue here now, okay? Now these numbers are a lot more manageable, so how might I change my 2, which is here, into a 6? The rule states you're not allowed to change the chemical formulae, so I can't change this number into a 6. No. So what you want to do instead is to multiply. So I can add a 3. So what I'm saying here essentially is, in this side, my container, I have hydrogen molecule, and a hydrogen molecule. So now I've increased the numbers, 2, 4, 6, easy peasy. This is the same, so now this is your balanced equation. So you usually get 1 mark for writing in the correct chemical formulae, and then the second mark is for the correct balancing. Now we'll do another example. So I think we will choose an example that's pretty straightforward. Let's do magnesium. So the symbol for magnesium is Mg. Let's react it with some oxygen, and our product, you've guessed it, it's magnesium oxide. So here we have our reactants. We are going to split it up. Remember, reactants from the products. These are our ingredients, these are what's made at the end. So let's do our shopping list method. Magnesium, there's no number after the magnesium or before, so we assume there is just 1. Oxygen, there is a number 2. Okay, let's move on to the second side. I like to do it in the same order. Doesn't get confusing when there's many, many more products. No number in between there, okay? And no number here at the front, just 1. Similarly with the oxygen, no number, so you have just 1. Right, let's just quickly check the imbalances. These two are balanced, so these seem okay. However, the issue is between the oxygen. We've got 2 on this side, and the law of conservation of mass states that what goes in essentially must come out. Okay, so we have 2 particles of oxygen going in, but we only have 1 here leaving, so that definitely doesn't make sense. So let's increase the number. So we need to change it to 2. Recall the rule which says we are not able to change the chemical formulae, so we cannot put a 2 here. Okay, what we can do is increase the number of molecules of magnesium oxide. So recall that we are now saying in our container, at the beginning there was a molecule of MgO. Now we're saying there's another molecule of MgO. Okay, so we're just increasing the numbers. So the oxygen now changes to a 2, 1, 2, and you can also see the magnesium number has been affected, so 1, 2. Let's cross that out. There we go. All right, so let's go back to our equation again. Now this time we have an imbalance with the magnesium. However, our oxygens are perfectly balanced. So you've guessed it, we need to increase the number of magnesium atoms on this side. We cannot, remember, write a number 2, that's wrong. We must write them at the front. There we are. So we're saying that they're in our container where we had 1 magnesium, now we have 2, and we balanced our equation. Brilliant, well done.